Alright, what's up everyone? This is LeetCode 136, single number. So we're given a non-empty array of integer nums. Every element appears twice except for one. Find that single one. So we have a bunch of elements, and basically every element but one element appears twice. And we have to find the element that doesn't appear twice, okay? So here, for example, 2 appears twice, but 1 appears once, so return 1. 2 appears twice, 1 appears twice, and 4 appears once, so return 4. So yeah, the actual premise of this problem isn't too hard. It's just the solution can be a little bit tricky to come up with, because you have to implement a solution with linear runtime complexity and only constant extra space. So you might think, okay, well, this problem's easy. You can use a hash set or a hash map, but of course that would be using that would not be using constant extra space, so that would not be the optimal solution. So the optimal solution is actually using bit manipulation. And it might not be super obvious at first because this problem doesn't give you any hints at the fact that this is a bit manipulation problem. Um, but if I tell you that this is a bit manipulation problem, right, and you don't understand still how this would be a bit manipulation problem, my advice is that you brush up on your knowledge for um, binary operations if the approach isn't obvious yet. I will show you the approach, okay, right now, but just know that this in hindsight, after you practice more, this problem is going to be pretty simple, right? Like what type of binary operation you would use to single out the number that appears once, okay? So let's start with an example, right? Let's say we have the number 10 in binary representation, which would be 1010. Okay. If we AND 10 with itself, right? What would that give us? That would give us 1010, right? Because 1 and 1, it gives us 1, 0, and 0 gives us 0, 1 and 1 gives us 1, 0 and 0 gives us 0, okay? If we AND a number with itself. Now, if we have a number and we OR it with itself, what would that give us, right? Well, that would also give us the same thing, right? Yeah, 1 and 1, but if we're doing OR, then that gives us 1. If we're doing 0 and 0, but we're ORing, it gives us 0. Okay, so we'd have the same result in either case if we're ANDing or ORing a number with itself. Well, that's not very useful, right, for finding out what element appears once or twice. But what if we're exclusive ORing a number with itself, right? Now, what does an exclusive OR do, right? Let's handle that. This is where you might not remember what it does. An exclusive OR, basically, if you exclusive OR a bit with another bit that is the same bit, it'll give you 0, okay? So for example, if we exclusive OR 1 and 1, it'll give us 0. If we exclusive OR 0 and 0, it'll give us 0. If we exclusive OR 1 and 1, it'll give us 0. Exclusive OR 0 and 0, it'll give us 0. The cases where it would give us 1 would be cases where we do like 1 exclusive or 0, that would give us 1, right? Now if we do 0 exclusive or 1, that would also give us 1. But if we do 0 exclusive or 0, that'll give us 0. 1 exclusive or 1, that'll give us 0 as well, okay? So now why is this useful? As you can see, well, if you exclusive or a number with itself, it'll basically just give you 0 as a result, right? Okay? So let's do an example, right? If we have something like 1, 2, 1, 2. Let me just write it like this just so it's easier. Okay. Now if we're doing something like this, right? I mean, it's the same approach, but there's kind of two ways you can kind of think about how to approach this. It'll give you the same end result, right? You can have like a result or a number, right? Like a starting number called or a certain number called res, and have set that to 0, and you can basically do, okay, this res exclusive that or with 1, take that result, exclusive that or with 1, take that result, exclusive that or that with 2, take that result, exclusive or that with 2, take that result, exclusive that or with 4, and in the end you'll be left with 4. You can do that, or you can just use this as kind of the starting number. Because if you exclusive OR a number with 0, it really doesn't matter. One exclusive OR 0 would give you 1, right? Basically, exclusive ORing 0 with a number, it'll give you whatever that number is. So I'll show you what I mean in the code later, but you can kind of use either approach. I'll just use the actual number, okay, as a starting number. So we'll 1 will be our starting number, okay? 1 will be our starting number, so think of this as our result. Okay. Move on to the next number. This result, which would be 1, so we have 1 exclusive OR that with the next 1. That'll give us 0 and 0, 0, 0 and 0, 0. Okay, 1 and 1 should give us what? 0. Okay. So now this is our result, except it's not. Our result is actually 0, 0, 0. Okay. The parentheses just means that's the number that we already handled, really. Okay, so this is our result. And we need to exclusive OR this with 2. So we'll do 1, 0, okay? Because 2 to the power of 1 is 2. Okay. So 0 exclusive OR with 2 should give us what? 0 and 0 should give us 0. 0 and 0 should give us 0. 0 and 1, though, should give us 1, okay? 0 and 0 gives us 0. Okay. So we handled this first 2. This is our result. So as you can see, when you exclusive OR 0 with a particular number, the result will just be that particular number, okay? Now, we have 2, and we have to exclusive OR that 2 with this 2. Okay, so 0, 0, 1, 0. Okay, let's exclusive OR this. 0 and 0 gives us 0. 0 and 0 gives us 0. 1 and 1 gives us 0. 0 and 0 gives us 0. Okay, so remember, see how when we exclusive OR a number with itself, it'll give us the result, which is 0. Okay, we handled that too. Now we have to handle what? This 4, right? Okay, well, our result is 0. Well, what do you know? When you exclusive OR 0 with a particular number, it'll give you that particular number, right? So 2 to the power of 2 is 4. So it's a binary representation of 4. Well, 0 and 0, let's exclusive OR this. 0 and 0 gives us 0. 0 and 1 gives us 1. 0 and 0 gives us 0. 0 and 0 gives us 0. So when we exclusive OR all these numbers, we're left with what? We're left with 4, right? See how when we exclusive OR all of this together, this 1 is canceling this 1 and giving us 0. This 2 is canceling this 2 and giving us 0. So all these exclusive OR together, the result of all that is 0. And 4 exclusive OR 0 should give us 4, right? Which is what we expect, okay? So that's how we're using bit manipulation to kind of solve this problem. Yeah, quite a few ways to solve this problem. So let's say if the length of nums is 1, we can just return the first number, okay? Because, well, there's only one number in the element in the array. Okay, this is what I meant when you can set your first number. You can set your first number as a result and then basically use that to exclusive OR the rest of the numbers. So we're going to say OR num in nums 1 res result is equal to the result exclusive OR the result with what? Num, and set that to the result. Okay, and then return result. What is this? So what this is doing is we're setting the result to 4 initially, right? And we're basically iterating in the for loop starting from the first index all the way onwards, okay? That's all this is doing, right? Basically, the first number is our result, and we're exclusive ORing this result with all these numbers in the for loop, right? So that's what I mean when you can use kind of 2 different approaches. It gives you the same end result, really. If you don't want to do that, though, what you can do is it might be a little bit cleaner actually to write it like this, right? So you can say for I in nums, and we can say we'll do this, okay? See, this is quote unquote our result, and we're gonna exclusive OR 0 with 4, which obviously will give us 4, right? And then basically take that 4 exclusive OR that with 1, with 2, etc., etc. Okay? Of course you can, give me a second. You can also write this a little bit cleaner by doing XOR equal with I, like that. So yeah. Pretty standard bit manipulation problem. You just need to make sure you understand what the actual operation is doing, okay? So yeah, this problem isn't too difficult. If it's difficult for you, you probably just don't have the best of knowledge with bit manipulation, but that's okay because um the more you practice these problems, the more obvious it'll be what you have to do and what this is doing. So yeah, just keep at it, and I hope this helped, and I'll see you in the next one.